Somewhere out there, past the reach of sunlight, something is on fire. Not a star, not an explosion, a world, an entire world, burning, and it has been burning for 4 billion years straight, without stopping, without cooling down, not even Onsei. This is not a distant galaxy or a sci-fi concept. This is happening right now, in our own solar system, on a moon you have probably never thought about. Its name is Io. It is Jupiter's closest large moon, and what is happening on its surface will completely change the way you think about what a moon can be. Stay with me, because what comes next gets wild. First, let's understand where Io actually lives. Jupiter is not just a big planet. It is an absolute monster. If you took every single object in our solar system, every planet, every moon, every comet and asteroid, and piled them all together, Jupiter would still weigh twice as much as all of it combined. Twice as much as everything else. Most of them are small, frozen, and completely dead, but 4 of them are enormous. We call them the Galilean moons, named after the astronomer Galileo, who spotted them over 400 years ago through one of the very first telescopes ever built. Callisto and Ganymede are massive frozen worlds covered in ancient craters. Europa has a shell of smooth ice, hiding a deep ocean underneath, and many scientists believe life could exist there. And then there is Io, the closest of the 4 to Jupiter, sitting just 350,000 kilometers above Jupiter's cloud tops, about the same distance as our moon is from Earth. Same size, same distance, completely different world. Because Io broke every rule we had about what a moon is supposed to look like. In 1977, NASA launched the Voyager 1 spacecraft on a grand tour of the outer solar system. When it came to Io, nobody on the science team was particularly excited. The outer solar system was assumed to be a frozen wasteland. Io was expected to look exactly like every other moon they had ever seen. Cold, cratered, dead. But when Voyager's cameras returned their images of Io, the room went quiet. There were no craters. None. At all, in a solar system where every single surface we had ever photographed was covered in impact craters from billions of years of asteroid collisions, Io looked freshly repaved. Smooth, colorful, almost alive. And then someone looked at the edge of the moon, where the surface curves away into space. Something was rising from it. A plume of gas and debris, climbing hundreds of kilometers above the surface. Then another one appeared. Then another. 9 separate volcanic eruptions. Captured in a single flyby, a NASA engineer named Linda Morabito spotted the first one while running routine image processing. What looked like a smudge in the data turned out to be one of the most important discoveries in the history of space exploration. Active volcanism beyond Earth, witnessed for the very first time in human history. And since that day, we've confirmed that Io hosts up to 400 active volcanoes erupting simultaneously. Right now, as you watch this video. Now, here's the question that changes everything. The Sun is over 770 million kilometers from Jupiter. It provides almost no warmth to this part of the solar system. The outer solar system is a deep freeze by nature. So where is all of Io's volcanic heat actually coming from? Pause on that for a second, because the answer is genuinely one of the most fascinating things in all of planetary science. The answer is gravity, but not just any gravity. A gravitational tug-of-war that has been running non-stop for 4 billion years, with Io trapped directly in the middle. On one side is Jupiter, pulling on Io with a force so overwhelming that it physically stretches and squeezes the moon as solid rock, not water. Solid rock, being deformed like a ball of clay in a giant's grip. On the other side are Io's neighboring moons, Europa, Ganymede, and Callisto, each one pulling back in the opposite direction with their own gravitational force. The result is that Io cannot maintain a simple circular orbit. It traces an oval path around Jupiter, sometimes closer, getting squeezed harder, sometimes farther away, relaxing slightly. This cycle repeats every 2 days. Every single day. forever. Here's an easy way to picture it. Take a metal coat hanger and bend it back and forth rapidly. Within 30 seconds, the metal at the bend point gets hot. You did not apply a flame. You converted repeated mechanical stress into heat. Now scale that up to a moon-sized ball of rock being squeezed by the most powerful gravitational field in the solar system every single day. For 4 billion years, that heat has to go somewhere, and it escapes through volcanoes. Scientists call this process tidal heating. On Earth, our moon pulls on our oceans and creates tides that rise maybe half a meter out in open water. On Io, Jupiter's gravity lifts the surface of solid rock by up to 100 meters. 100 meters of ground heaving upward and falling back, like a slow planetary heartbeat, every single day. Now, close your eyes for a second and imagine standing on the surface of Io. The sky above you is completely black, even in the middle of the day. There is no thick atmosphere to scatter light, just darkness and stars. On the horizon, Jupiter hangs impossibly large. You can see its storm bands slowly turning. The ground beneath your feet is pale yellow and unnervingly warm, and in the distance, something is rising. A towering column of gas and sulfur, climbing hundreds of kilometers above the surface before slowly arcing back down in a graceful slow-motion fountain of fire. This is not a rare event on Io. This is just another Tuesday. The colors you see across Io's surface are all painted by sulfur in different states. The bright yellows are crystallized sulfur that has settled across the cooler zones, essentially forming a kind of alien snow. The dark reds and blacks mark fresh volcanic activity where eruptions are still ongoing, and the green tints visible in the upper atmosphere are created by chemical reactions between the sulfur gases and the intense radiation pouring out of Jupiter's magnetic field. And then there are the lava lakes. Because Io has no tectonic plates, volcanic eruptions here do not build mountains. Instead, the surface collapses inward and molten rock fills the void from below. The largest of these lakes is called Loki Patera. It spans 200 kilometers across. That is roughly the distance you would cover driving on a highway for 2 solid hours. In the center sits a solid island of hardened rock, surrounded on all sides by a slowly churning sea of liquid fire. Scientists have watched this lake go through cycles where fresh lava overturns the cooled surface crust, rolling around the lake like a wave of fire that takes about 18 months to complete one full rotation. 200 kilometers wide. 18 months per cycle, just sitting there on the surface of a moon, right now, in our solar system. But here's where things get genuinely strange. And I mean strange, even by Io standards. If there are no tectonic plates on Io, and if volcanic activity tends to collapse the surface rather than build it up, then where did these come from? Io is covered in enormous solitary mountain peaks that burst from the surrounding terrain with no warning whatsoever. No mountain ranges, no foothills, no gradual slope leading up to them. Just sudden, dramatic spires stabbing straight up from flat ground like needles, pushed through fabric from underneath. The tallest ones rise 18 kilometers above the surface. Mount Everest, the tallest mountain on Earth, is 8.8 kilometers high. These peaks on Io are more than double that. One of the most striking is known as Steeple Mountain. Its sharp angular silhouette, rising against the black sky, with Jupiter glowing behind it, looks almost too dramatic to be real. We got detailed images of these mountains, thanks to NASA's Juno spacecraft, which completed 2 close flybys of Io in December 2023 and February 2024, passing within just 1,500 kilometers of the surface. And the leading theory for how these mountains form is as strange as the mountains themselves, as sections of Io's surface continuously collapse inward from volcanic activity. The pressure forces nearby sections of rock to buckle and thrust violently upward. Every time a piece of ground sinks, something close by gets ejected toward the sky. The mountains of EOA are not slowly built up over time. They are squeezed out of the ground by pressure. Suddenly, dramatically. Like the Earth itself decided to throw a punch, and eventually, the same volcanic resurfacing that created them will bury them completely under a fresh layer of lava and sulfur. On a geological timescale, they are here and gone in the blink of an eye. For a long time, Scientists assumed the inside of Io must look like the inside of Earth. A solid outer crust floating on top of a global ocean of magma. Clean, simple, predictable. But the actual data painted a different picture. Probes passing through the Jupiter system were able to measure subtle variations in the gravitational pull around Io's surface, and what they found is that the pull is uneven, lumpy, inconsistent. That tells us the magma inside Io is not evenly spread out. There is no single global ocean of molten rock sitting beneath the crust. Instead, the heat is concentrated in hundreds of isolated pockets scattered throughout the interior, each one sitting in the zone that experiences the most intense gravitational squeezing. Io does not have one volcanic engine powering everything. It has hundreds of them, all running at the same time, each one behaving slightly differently, each one connected to its own local heat source. And this entire system has been running continuously for approximately 4.5 billion years, the same age as our solar system itself. Io has never had a quiet period. It has never frozen over. It has never rested. Every single feature on its surface today is just the latest frame in a 4 billion year film of non-stop destruction and renewal. You might be wondering, with everything we just covered, why is there no dedicated mission heading to Io right now? 2 major missions are currently on their way to the Jupiter system. The European Space Agency launched a probe called JUICE, short for Jupiter Icy Moons Explorer, in 2023. It will arrive around 2031 and will focus on Ganymede, Callisto, and Europa. NASA launched the Europa Clipper in 2024. It arrives in 2030 and is aimed directly at Europa, searching for signs of life in the ocean beneath its ice. Both of these missions are extraordinary, but neither of them has Io as their primary target. Part of the reason is purely practical. The radiation environment near Io is brutally hostile. Jupiter's magnetic field traps, high-energy particles, and bomb. The inner moon system with radiation intense enough to destroy spacecraft electronics within hours. Building a probe that can survive an extended stay near Io is an enormous engineering challenge, and part of it is simpler than that. Alien life gets headlines. Alien volcanoes, no matter how extreme, are a harder sell to funding committees. But the Juno flyby images from 2023 and 2024 changed the conversation. The scientific community took one look at what those images revealed and collectively acknowledged that we have barely scratched the surface of what Io has to teach us. Proposals for a dedicated Io orbiter mission are gaining serious momentum. It may be closer than we think. Here's why Io matters beyond just being a spectacular and violent place. Tidal heating is not unique to our solar system. Across the universe, planets and moons exist in gravitational situations similar to Io. Some of them orbit so close to their host stars, or exist in systems with multiple massive neighbors, that tidal heating may be their dominant energy source, far outweighing anything they receive from sunlight. Io is the only place in the universe where we can observe extreme tidal heating up close, in real time, with actual instruments. Every eruption we document, every mountain we map, every lava lake we study. All of it builds a framework that scientists can apply to distant worlds we may never physically visit. Io is our laboratory, our real-world reference point for understanding what gravity-driven heat actually does to a world over billions of years. And it has been running this experiment for us right next door, this entire time. So let us bring it all together. Io is Jupiter's innermost large moon, roughly the size of our own moon. But unlike anything else in the solar system, up to 400 active volcanoes erupting simultaneously, powered not by proximity to the sun, but by a gravitational tug-of-war that has been running for 4 billion years without stopping. Tidal heating stretches and squeezes its solid rock surface by up to 100 meters every single day, generating enough energy to sustain the most extreme volcanic activity we have ever witnessed anywhere. Lava lakes hundreds of kilometers wide, mountains twice the height of Everest that burst from the ground through pressure rather than building gradually. A surface that gets completely repaved by fresh volcanic material on a timescale that makes our entire human history look like a blink, and we have barely started to understand it. If this video changed the way you think about what a moon can be, hit that subscribe button right now. Every week we cover the most extreme, most mysterious, and most mind-bending stories in space exploration. Drop a comment and tell me this: If you could send one probe anywhere in the solar system right now and get instant results, where would you send it? Io or Europa? I read every single comment. See you in the next one.